All right, the second trend we're going to go over is about ionization energy, but we have to do a little bit of a review from our atomic theory chapter about what an ion is. Remember, ions are charged atoms. They are really important, and these are not going away. Okay, the way that they are charged is because they have different electrons. They don't have different numbers of protons. Protons stay the same. Okay, so we can have cations and anions. And in this video, we're going to talk about this video we're going to talk about cations with ionization energy, and then with anions, we're going to talk about electron affinity. And then we'll talk about ionic radius in the fourth trends video. Okay, our cations are going to be positively charged atoms because they lost their outer electrons. And anions are negatively charged because they gained more electrons than their protons. Okay, so that's a little review for you. So our second trend that we're going to go over is ionization energy, or IE for short. Ionization energy is the energy needed to remove an electron from an atom, forming a positive ion, or a cation. Cat or positive. Okay, there are multiple ionization energies. There's first ionization energies, how much it takes to remove one, the outermost electron. Second ionization energies, in order to make a 2 plus, there's third, fourth, etc., etc. There's a table in your book. You can check it all out. But we're really concentrating with just removing that first electron here. All right, so let's think. As we travel down a group, the first ionization energy, the amount of energy it takes to remove an electron, will decrease. That means it is easy to decrease. Okay, that it is easy to remove, um, not decrease, to remove an electron. Why? Why is it easy to remove electrons as we travel down the group? It all goes back to the radius. Atoms are larger. So if they're larger, here's your nucleus in the center, and there's your electron out there. Okay, look at all the stuff that's shielding its way. Basically, these electrons are like the wallets of Frankenstein, or my Uncle Frank. And it's really easy to steal from Frankenstein. He's slow, he's big, and he's cumbersome. All right, so it's going to be easy to steal from big things. Not that I condone stealing, don't get me wrong. So what's going to happen as we go across a period? As we go across a period for those representative elements, it's going to take a lot of energy. It's going to be really difficult to steal from those little munchkins from Wizard of Oz. Okay, they have, remember, a very strong nucleus and those shrink-wrapped electrons that are being pulled down. Okay, the greater the nuclear charge, there's more attraction for the electrons, and it's going to be harder to remove. This reason why is always going to be the case, because they're smaller as we go across, because the nucleus is pulling down on those electrons, making it more and more difficult. Okay? So what you'll see is that for ionization energy, this is where all the lowest ionization energies are, and this is where all the highest ionization energies are. So what side of the periodic table is going to make cations? Who's going to lose their electrons easier? This side. This is where the cations are. The cations are all the metals. All right, the metals are going to make the cations. It's pretty amazing. Okay, so again, this is where you're going to have the lowest ionization energy, and this is where you're going to have the most ionization energy. Most energy to remove electrons, least amount of energy to remove electrons. So what I'd like to do is have you guys draw on a piece of paper the trends yourself, and it really helps you memorize them. Okay, so draw yourself a very easy periodic table. Okay, it can look just like that. And then we draw our first trend, atomic radius. As we travel down, you're going to see that the radius is going to increase. And you can put on the periodic table, hey, I have big Uncle Frankenstein. And over here, it's going to decrease. And I'm going to have teeny tiny helium. And that might help you with the perspective of the whole thing. Next, we have ionization energy, the amount of energy it takes to remove an electron. So as we travel down, it's going to decrease, and you're going to see it's really easy to remove electrons here. But as you travel across, because they're smaller, it's going to increase. So that means my cations, which are positively charged, are on the left-hand side of the periodic table. Okay? So let's take a look at our elements and put them in the correct order. Put these elements that we used in the other video and put them in increasing ionization energy. So again, ionization energy as we travel down is going to decrease. As we travel across is going to increase. Okay, so we have carbon, we have nitrogen, we have lithium, we have fluorine, and we have oxygen. Do I write them as Li, C, then N, then O, then F, or F, O, N, C, Li? Okay, I'll give you a second. I want them in increasing order. The trend increases to the right. Do I write them as Licnof, Lichnoff, or Foncli, Foncli? The correct answer is Lichnoff, Licno, then F. Okay, this is going to have the lowest ionization energy, and this is going to have the highest because it has the smallest nucleus. Okay, increasing means small to big. And yes, sometimes I need to write that down because sometimes we get a little confused about that. All right, so that is ionization energy, electron affinity coming up.